till the end of the instruction, end of the program, and the opcode values of those mnemonic operation code values also are given, mnemonic symbols. Okay, it is also given. Right now you need to start generating the object code. Okay, again as usual, if you ever remembered, so as we have the pass 1 and pass 2, right? We have the pass 1 and pass 2 of us, your assembly process. In the pass 1, you only think of assigning the addresses. I repeat, you will only think of assigning the addresses. For suppose if at all if you want to assign the address, okay, not to assign the address, so the pass 1. So for this, let me have one. Yeah, let me insert one extra column to the left side. Yeah, so I'm like this is for address field. I am just using one extra column right here. Okay, and also I hope you remembered. So when it comes to address assignment, so you have to start assigning based on the starting address. Students, can anyone of you let me know what is the starting address for the program?
0000.
Exactly, because so whatever the address it is given with the start instruction, that itself would be act as a starting address. So I'll take zeros itself as the starting address, and I'll start assigning from the next instruction. Now again, I hope you remember just before this session I told you like the different instruction formats in SIC, EXE. There are totally 4 instruction formats. I repeat, there are totally 4 instruction formats. My dear students, how to identify them in the sense? So remember, my dear students, so how to categorize them in the sense, in any instruction, if you are using only opcode, so which will be a format 1. Whereas the second type, so I hope you remembered, I shown you here, not where is that? Yeah. So here I shown you like, so these are the different instruction formats. Okay. So if you have only opcode, it is a format 1 for which you need to allocate only 1 byte. If your instruction has opcode followed by register 1 and register 2, that's what only registers. I repeat, if your instruction has opcode with only registers, then it is a format 2 for which you need to allocate 2 bytes. And format 3, wherein you will never deal with only registers, you will be also be dealing with the operand, and which will be having a respective address, which is format 3 and format 4. Again, how to categorize? So here in this example, if you observe, this is what LDS #10. So so you can observe it is not only the opcode, so it is also having operand. So it cannot be a format 1. At the same time, it is not acting as only format, it is not acting on only registers. My dear students, these two you can observe right here. So in these two you can observe, these are the two instructions which are working only on the registers. A and the S registers, S and the T registers. Understand, my dear? A and the S are registers, S and the T are registers. So these are the two instructions working only on the registers. So which are belongs to format 2. Rest other instructions like these and also these. This instruction belongs to either format 3 or 4. I repeat, either format 3 or 4. Again, how to categorize whether it is a format 3 or the 4 in the sense, my dear students. So understand clearly, in the format 4 or in the format 3 and the 4. I hope you cleared with the format 2. So these kind of instruction which are working purely on the registers, which are belongs to the format 2. Rest all these are belongs to format either format 3 or 4. Again, how to categorize whether they are belongs to format 3 or 4. I repeat, how to categorize whether they are belongs to format 3 or 4 in the sense, so that you can categorize based on the opcode. If the opcode is preceded with the plus like this, understand, my dear students, in your program, if the opcode is preceded with the plus, then it is format 4. If it is no plus, nothing like this, if it is LDT like this, that's what. Without the plus, if you have something, then it is a format 3. I repeat, if in your instruction, I repeat, my dear students, in your instruction, if it is preceded with the plus, then it is format 4. If there is no plus, it is format 3. As of now, you can observe, these are the instructions which do not have any plus right here for the opcode. So they are belongs to format 3 only, for which you need to allocate only 3 bytes. So as when you allocate 3 bytes to this instruction, so the next address would be 0003. Again, this is format 3, so for which you need to allocate 3 bytes, so it will be 0006. Again, next instruction is LDAN, which again it is a format 3 because it is neither preceded with the plus or it is not acting only on the register, so it is format 3 only. So the next address would be 0009. Now when it comes to the add r a comma s, I repeat, when it comes to this add r a comma s, it is purely belongs to format 2. I repeat, it is belongs to format 2. As it belongs to format 2, so for which how much memory space you need to allocate in the science, you have to allocate 2 bytes. But so when you want to allocate 2 bytes, so the next address would be what? So 9 plus 2, it is 9 plus 2, it is 000b,
B.
because 9 plus 1 is a and the b. Again you have sub r s comma t, which is again a format 2 because it is acting only on the registers, so for which again you need to allocate only 2 bytes. So next address b plus 2 you get as 000d. Again you can observe STTM, as it is STTM, so it is not acting only on the registers, so this can be either format 3 or 4. Again I said, if it is plus here, if it is plus like this, then it would be format 4, but right now it is only just STT, so it is not belongs to format 4, it is belongs to format 3 itself, so for which you will be allocating 3 bytes. Now D plus 3 is what? D plus 3, can anybody? 000. Students, D plus 3.
10.
Yeah. D plus 3. What is D? What is D, my dear? Guys, can you hear
13,
me?
sir. 13.
D is not 13. Yeah, sorry. Yeah, D is a 13. So D 13 plus 3 is what? 16. 16 means what? 1
1,
0.
1.
1 0, not 1 1. So F is 15. 16 is what? 1 0. Okay, so again here is n reserve word 1, so for which again you need to allocate, so as it is based on this reserve word, as it is reserve 1, so it is 1 into 3 means 3 bytes. If it is reserve word 10, 10 means 10, so 10 into 3 it would be 30 bytes. So I hope you are clear. This kind of concepts even we saw in the SIC also from our previous examples. I hope you are clear with that. So now it is reserve word 1, so how much memory space need to be allocated, guys?
0013.
So 3 bytes need to be allocated. So you get 0013. Again you have M reserve word 1. So how much memory space need to be allocated? 3 bytes. So what would be the next address? 0016.
17.
17 or 16?
16, sir.
Yeah, 3 plus 3 is 6. So right, so this is how we are done with the phase 1 or pass 1 of your assembler, where we generated the, or not generated, assigned the addresses for the each instruction. Based on this you can also generate the symbol table. So when you generate the symbol table, okay, when you generate the symbol table, where you can have a respective symbols with the addresses, symbol table. So here we have a symbol table where it has very only two symbols I need to consider. It is n and the m. So what is the address of n, my dear students? What is the address of n? It is 0010, whereas the address of m is 0013. That's it. So I'll be considering only the 0010 is the address of n, and 0013 is the address of m. So I'm done with the address assignment and also symbol table generation. Both are done. Now I need to take you to the object code generation. My dear students, I hope you are getting my point. If not, you guys can ask me. Okay, now I'll take you to the object code generation. For the point of object code generation, or for object code generation, how do we generate in the sense? Again, you have to make use of, or you have to bother about the instruction formats and also the addressing modes. I repeat, instruction formats and also the addressing modes. Now what I have to do in the sense here, I hope you remember, this is what I said at the time of address allocation itself. I told you this is belongs to format 3. So take up the format 3. How exactly is for your format 3? If you ever remembered your format 3 instruction, how it is, how it looks like. So I'll just keep it simple. Okay, what you had actually, what you had means you had a opcode. What is the length of opcode means you can observe it is of only 6 bits, followed by you have N, I, X, B, P and E, and followed by you have the displacement. So you had N, I, X, B, P and E followed by the displacement. What is the length of displacement, my dear? In case of format 3, it is of 12 bits. So you have to keep that also in mind. Now, so this is what the instruction format. Let me make it this somewhere more. Okay, so if you guys have any doubts, you can ask me in between, my dear students, but don't get confused, try to understand clearly. I'm just taking the very simple example in the today's class. So further I'll be taking you guys to the somewhat complicated as well. Now if I take you to the this is what the format of the format 3 which I'm talking about right now. Now this LDS hash 10, definitely LDS hash 10 is a format 3. So this is the format opcode followed by NXBP followed by the displacement. Now my dear students, what is the length of the opcode? Length of the opcode is 6 bits.
6 bytes.
6 bits. Okay, and here the what is the opcode here? It is the LDS mnemonic. What is the symbol here? It is LDS. What is the opcode of the LDS? Here it is given as, guys, what is the opcode here which I mentioned here?
6C.
So it is 6C. My dear students, this is very important concept to understand. 6C, how to write 6C? It is 0110 is 0110 is 6 and 1100 is C. I repeat, 6C, how to write 6C means 0110 is 6 followed by 1100 is C, which is 12. But if you write that 6C completely, you need 8 bits. Observe, you need 8 bits but your opcode field is of only 6 bits. So you cannot fit 8 bits into the 6 bits. Students, are you getting? So you can't fit 8 bits into the 6 bits. So what you have to do in the sense, the last 2 bits you have to neglect. Either it can be ones or zeros. I repeat, my dear students. I repeat, guys. So if you are not getting, please ask me. This is very important and very simple as well. Okay, here is the opcode is LDS. The opcode of LDS is 6C. When you write 6C in the bit format, you will get like this. But in order to fit that 6C, you need totally 8 bits. I repeat, you need totally 8 bits you want. But the thing that the field is of only 6 bits, not 8 bits. So in order to fit the 8 bits into the 6 bits, the last 2 bits, irrespective of zeros or ones, either it can be zeros or ones, you have to neglect the last 2 bits. So that is where you will be making it as 6 bits. So you will be getting it as 6 bits. Students, did you get how we are going to make it as 6 bits?
Yes, sir.
So
Yes, sir.
irrespective of zeros or ones, so the last 2 bits you have to neglect. So whereby you will be making it as 6 bits. So what is going to happen right now? 8 bits are converted to be a 6 bits, right? Now next, let us take you to the this LDS. So we are done with the opcode. Now let us take you to the NXBPE. First thing is that, so let me make it as simple as possible for you guys. First and foremost thing, so it is a format 3. So for format 3, what is the value of E? I told you E will be 1 for format 4 and 0 for format 3. So E is 0. And is it making use of X register? No. So I'll make it as X as 0. I'm just making for your guys, as this is the first example I'm taking. So I'm taking with the simple things instead of a continuous. Okay. Next, coming to the N and I. So what is N and I? So if you ever remembered in case from our addressing modes, here if you ever remembered addressing modes with respect to N and I, we have the 2 cases. Either it can be immediate or it can be indirect. I repeat, it can be immediate or the indirect. For the immediate addressing mode, I will be 1 and N will be 0. For indirect, N will be 1 and I will be 0. My dear students, remember, all of you, just remember right here, if your operand is preceded with the hash, I repeat, if your operand is preceded with the hash, then it is a immediate or indirect. Can any one of you? If your operand is preceded with the Yes, if your operand is preceded with the hash, then it is a immediate addressing mode for which I will be set as 1, whereas n will be set as 0. I repeat, n will be set as 0. Whereas if you ask me how to identify the indirect one means, so however you have a hash here, if you have the symbol like @ symbol, I repeat, instead of the hash, if you have @ symbol here, instead of hash, if you have @ symbol like this. So just for your understanding, I'm just telling you, instead of this hash, wherever you have operand is preceded with the hash, right? There, if you have this @ symbol, then it would be, so you will never have both in the same instruction. I'm just telling you. So without, instead of hash, if you have @ symbol, then it is a indirect addressing mode. Mind about it, my dear students. So if you have hash, then it is a immediate. If you have @ then it will be indirect. Now, so as it is immediate, then now come, let me take you to the B and the P. What did I say? B and the P belongs to the base relative or program counter relative, that's what PC relative, and those will be applicable only in format 3. Now, even the instruction which we are talking about is also format 3. The instruction whatever we are speaking is also format 3. So this instruction could be either format 3 or 4. I repeat, this, sorry. This could be either base relative or the piece relative. I repeat, this can be either base relative or the piece relative. How to find out that? For that, very importantly, in order to set this B and the P, my dear students, in order to set this B and the P, you have to first find out this displacement. What did I say in case of format 3? In case of format 3, this displacement, I told you that it is nothing else than the relative address. Displacement is nothing else than the relative address. How to find out that relative address? How to find out this relative address? My dear students, so here you can also make a point how to find out the relative address or the displacement. If you ask me, it is by using a simple formula that displacement, you may also call, this displacement is also called as what? Relative address. I repeat, you may also call this displacement as relative address. Let me simply say that RA, which you can find out as, how to find out in the sense, it is operand address minus, it is operand, not, yeah, operand address minus PC value. I repeat, operand address minus PC value. This is the simple formula we will be using to find out the displacement of 12 bits. The displacement, you may also call it as relative address. Keep in mind, there is so much of story we are going to discuss in the further classes about that relative address. Keep that in mind. How to find out relative address in the science, it is by using the formula operand address minus the PC value. Now, my dear students, now as of now in this instruction, what is the operand? Students, can anyone of you let me know what is the operand here in this instruction, LDS #10?
#10,
So exactly, #10 itself is the operand. Understand, my dear students? #10 itself is the operand. So what is the address of #10? It is not nowhere, because #10 is not defined anywhere. So the as it is #10 is the operand. My dear students, understand. So operand is what? #10. So you are not defined that anywhere in your address. So you cannot this displacement, what would be the displacement in the sense that #10 itself. That is what 10 itself. But that 10 you have to write in the 12 bits formats. How to write it is 000 followed by 0001 followed by 000. That's how we'll be writing as 010, which is nothing as 10. And am I finding out the displacement by using PC value? I'm not finding out the displacement by making use of either PC value or base register. So both will be set as zeros. I'm just making it to be a very clear, my dear students. Even if you want, so right here, I'll just take you to the one more example so that again I can come back so that you may understand a little better. So you try to understand. Right here we made use of displacement is nothing else the operand itself, because the operand is the immediate value, so that itself is acting as a displacement. So for finding out the displacement, we neither made use of base relative, we neither made use of base register or the piece register. So both are set as 00. Now if you find out the object code, if you see 00010, which is 6. Again, you have 2 bits here. Those 2 bits need to be combined with these 2 bits. So these I repeat, these 2 bits has to be combined with the 2 bits of n and the I. I repeat, 2 bits of n and I. So when you combine this 1101, which is 1101 is what? D. 1101 is D. Again you have 4 bits, 0000. 4 zeros means 0. Again you have 4 zeros, which is 0. Again you have 0001, it is 1. And finally 4 zeros, it is 0. This is what the object code. I repeat, this is what the object code we are getting. Okay, I hope you are understanding. If you are not understanding, please ask me. Now, okay, LDT hash 5, I'll come to that. So I'll directly take you to the LDA n because I want you to understand the actual concept of relative address. LDT 10, LDT hash 5, I'll come to that later. LDA n, I'll take you to this LDA n directly because to make you to understand the actual concept of relative address or the displacement, so whereby we'll be setting the P and the B. Okay, so in that perspective, what is the opcode here? It is LDA. What is the opcode value of LDA? It is 00. But how to write in the 6 bits format? It is 4 zeros followed by 2 zeros. That's how we'll be writing in the 6 bits formats, right? Next, again, if you ask me, so now guys, my dear students, tell me whether the n is preceded with the hash or the at the rate. Does the n is preceded with the hash or at the rate? Does the n is preceded with the hash or at the rate?
Not both, sir.
So not both, right? So when you see here, when the respective operand is neither preceded with the hash nor the at the rate, then it is a simple addressing mode. You can say it is a simple addressing mode for which both n and the I will be set as 1 1. Then again, is it making use of X register? No. So it is 0. Again, is it a format 3? Yes. As for format 3, it is 0. Now I just left this B and the P is empty. I just left the B and the P is empty. We'll fill that later once after we find out the displacement. Now again, how to find out displacement? Already I had given the equation that we will be finding out by making use of operand address minus PC value. Okay, we'll be finding out by making use of operand address minus PC value. Now here in this instruction, can anyone of you let me know what is the operand in this instruction, which is in the LDA n? What is the operand?
N, sir.
So operand is n. So in this particular you can observe the operand is n. When the operand is n, okay, as the operand is n right here. So what is the address of the n? You can observe the address of n is what? 0010. So here for your understanding, let me place one more one more value here. So what is the operand here? It is the n. So what is the address of that n? It is what? 0010. Right, that is the operand address minus I said PC value. See, for when you are pointing in this instruction, obviously PC will be pointing to the next instruction. So what is the next the PC address? It is the 0009. So PC value for this instruction is what? 009. I hope you got this point, how you got 009. If not, you can ask me, my dear students. So here n is the operand. I repeat, n is the operand. And the address of that n here, we got to know from the symbol table that 0010 is the operand address. Whereas when we are working in this instruction, PC will be pointing to the next instruction. That is what program counter, right? So what is the address there? It is 0009. So it is 0010 minus it is 0009. My dear students, if you ask me, this 0010 is not 10 in the decimal, 10 is in the hexadecimal. Now if you subtract 10 minus 9, what is the value you are going to get? 10 is not in the decimal. You have to mind about it. So 10 in the hexadecimal minus 9. So it is all same as 16 minus 9. If you want, I'm just showing you right here. If you want, you can also observe right here. Okay. So it is in the hexadecimal. In the hexadecimal, it is 10 minus 9 is equal to what? 7. It is all same as 16 in the decimal minus 9 is what? 7. So you're getting us what? 0007. I'll say only 2 zeros followed by 7. Students, are you understanding?
Yes, sir.
And what is the displacement you got? It is 007. and let me quote as 0 0 0 0 and 0 0 0 followed by 0 7. 7 means 111. So this is the displacement. Now you tell me to find out this displacement. When you find out the displacement, what is the value you got? 007. I repeat, you got the value as 007. This is where very important point, my dear students. What is the displacement I got? It is 007, and that 007 I have to check with the this. If you ever remember, if that resultant value is in between the 0 and the, here it is, first you need to go for the PC mode. So if that resultant value is between the 2048 to the 2047 minus 2048 to the plus 2047, then you need to consider as PC relative. What is the value we got? It is 007. Does that 007 is it is within the range of this PC? So it is definitely less than 2047. So as it means to say that we found the displacement, which is relative address, by using what? By using the PC address. This 0009 is what? PC address, right? By using the PC address we found. So as we found the displacement by using the PC address, so we'll be setting P as 1 and B as 0. Mind about this, my dear students. What I'm trying to convey in the sense, when you find out the relative address, based on that relative address, as that relative address is between this range, which is within the 2047. So if it is more than 2047, you cannot consider as PC mode. You have to shift it to the where? You need to shift it to the base relative. Mind about it. Okay. So if it is more than 2047, you should go to the base relative. As now it is less than the 2047, it is PC mode. So for which we set P as 1 and B as 0. Students, are you getting? So here we made it as both 0 0 because to find out the displacement, we neither made use of B or P, because we made use of a direct value of hash 10 itself as a displacement. So we did not made use of either B or the P, so both are 0 0. Whereas here to find out the displacement, we made use of PC address. We made use of PC value, which is 009, the program counter address. So it is belongs to the PC mode. Students, are you understanding?
Yes, sir.
Now based on this, what is the object code? You can observe it is 4 zeros, it is 0. Again 0011, it is 3. Again 0010 is what? 2. Followed by 0. Again followed by 0. Again followed by 7. That is the object code. Students, are you getting? This is a very simple example which I considered. Students, are you understanding?
Yes, sir.
Now, so if you understood this, then let me take you to the LDT hash 5, which is as same as LDS 10. So what is the opcode of LDT? It is 74. How to write 74? It is what? 0111 is 7, and how to write 4? It is 0100. 4 is what? 0100, but we have to write as only 01. Again, it is hash 5. Can anyone of you let me know whether it is what addressing mode is this? Immediate, for which n is 0. N is 0, 1 I is 1, and it is not using X as well. Again, coming to the E, it is 0. Then what is the displacement? As it is a operand is the direct value, so there won't be any kind of operand address. So this phi itself will act as the displacement. When you say that, okay, just a minute, my dear students. Sorry, actually for this. I'll why I'm asking sorry, I'll come to that. So here the phi is the value, right? So you'll be writing as 0 0 0 followed by 0 0 0 followed by 0 1 0 1. It is phi. And as usual, for finding out this displacement, we never made use of any B or the P, because it is a direct value. So both B and the P are 0 0. Okay, you got this LDA hash phi? Sorry, LDT hash phi, students?
Yes, sir.
Okay, the reason why I asked you sorry in the sense, this LDS hash 10, yes, we made use of 10, but you cannot write, sorry, so for this only I'm asking sorry, you can't write as 10. This because whatever this 10 is there, no, it is the decimal 10. I repeat, this is the decimal 10. The decimal 10 you can't write as this. Decimal 10, when you convert to the hexadecimal, it will become a. It would become A. It is not 10. So for that I'm asking sorry. So here if you say A, this 10, when you convert this 10 to the hexadecimal, it will become A. When you convert 5 from decimal to hexadecimal, it will be 5 only. But when you convert 10 to the hexadecimal, it will become A. In such case, it is nothing else 00 A. So 0 0 A means what? A is what? 1 0 1 0. Right, 1 0 1 0. So as it is changed, so even the object code is also changes. 0 A. This is the object code. For that I asked this all. Okay, is it clear right now? So did you understand why you got A here, students?
Yes, sir.
Now what is the object code for this LDT 5? So it is what? 7. Again you can observe it is 0 1 0 1. 0 1 0 1 means what? 5 followed by 4 zeros, again 4 zeros and 5. That's the object code for the LDT hash 5. I hope you are understanding. If you're not understanding, please ask me. Okay, next let me take you to the next instruction, which is very important, which is add RA, and I told you this is a format 2 instruction. It is not format 3. It is neither format 3 or not format 4. It is a format 2 instruction. What is the format of format 2 instruction? If you ever remember, see, it is what? Opcode followed by register 1 and register 2. I repeat, it is, let me place it separate table for that. So students, if you are not understanding, please ask me. You don't be idle, because these are very important to understand and work out. Okay, so now I hope it is visible to you all. Now based on your what does your format 2 says? Based on your format 2, you can observe format 2 says that opcode is of 8 bits followed by register 1 and register 2 is of 4 bits each. That's what you can observe. That's what opcode is of 8 bits followed by register 1 and register 2 is of 4 bits each. Now what is the opcode here? It is add R. What is opcode of add R? Adder is what? 90. So you have to write as 9. How to write 9? It is 1001 is 9 followed by, I repeat, 1001 is what? 9 followed by 0, 4 zeros. So I have to write all the 8 bits, my dear. Keep in mind, I have to write all the 4 bits, all the 8 bits. No need of neglecting, because in the format 2, opcode size of the opcode is of 8 bits. So as the size of the opcode is of 8 bits, so you don't have to neglect anything, right? Then later it is what? Register 1 and register 2. What is the register 1 here? It is A. What is the register 2? It is S. But what are those values? Can anyone of you guess and tell me what are the values of A and S? What is the register value of A?
So 0 and 4.
Exactly. So how to find out the values of the A and S in the sense, my dear students? It is again we had the register numbers, if you remember. So here we had, right, register numbers. What is the register number of A? It is 0. What is the register number of S? It is 4. So only I told you to remember these register numbers when I taught you this registers in SIC XE as well, right? Now based on that, what is the register number of A? It is 0 0 0. Again, what is the register number of S? It is 4, right? How to write it? It is 0 1 0 0. Now based on this, what is the object code you get? It is what you can observe. It is what? 9 followed by 0 0 4. That's it. Because even you allocated only 2 bytes. For the 2 bytes, you can only have only 4 hexadecimal numbers. This is what the object code for adder A, S. The same way, what is the opcode of sub R? It is 94. I'll say 9 and 4 followed by S and the T. What is the register number of S? It is what? 4. What about the T? What is the register number of T? So register number of T is what, my dear? What is the register number of T, students? 5. So how to write 5? It is 0 1 0 1. So what is the object code you get? It is 9 4 4 5. Right? So that's the object code for the. Can you observe right here? What in case of SIC, we had the same kind of object code for all the instructions, because there was only one type of instruction in SIC. Whereas here we have the different kind of instructions like format 1 3 4 1 2 3 4. So you will have the object codes also in the different way. For format 3, it is 3 bytes, so total 6 hexadecimal. Format 2, 4 hexadecimal, 2 bytes. In format 4, no, you will get 4 bytes, right? You will get 8 hexadecimal numbers. Okay, I hope you are getting. Now let me take you to the last one, which is STTM, right? So let me take you to the STTM. For the as STTM, again it is a format 3 instruction, right? STTM is a format 3 instruction. What is the opcode of STT? So opcode of STT, it is STT. STD is what? 84. So opcode of STD is 84. So you already has 8 and 4. It is only 0 1 because it is format 3. In format 3 it is of opcode is of only what? 6 bits only. So it is 8 4 followed by, it is neither indirect nor immediate because it is not preceded with either hash or the at the rate symbol. So it is neither indirect nor immediate. So 1 and the 1. Again, it is not using X register. Again, followed E is 0. It is because it format 3. Now again find out the displacement. How to find out the displacement? As we said earlier also. So as we said earlier also, you need to find out the displacement by using the formula what? Operand address minus PC value. In this example, what is the operand here? It is M. M is the operand. What is the address of that M? It is 0013. So it is 0013 minus PC value. As I am pointing out this STTM as the current instruction. So what is the PC? What is the PC value? PC value is what? 0010. So 0010 would be the PC value. Okay, so when you do this 0010, when you do this, which is 0013 minus 0010, so you'll get 0003. I repeat 0003. That only I need to make it out, which is 0 0 and 3 in the 12 bits format. Again same way, whether this 0003 is in the within the range of 2047, is it less than 2047? Definitely yes. And for finding out this operand address, sorry, for finding out this displacement address, right, relative address, I made use of PC. So I will set as P as 1 and B as 0. So based on this, what is the object code you get? Here it is 8 followed by 0111, which is 7, followed by 0010, it is 2, followed by 003. That's the object code for that instruction, which is STTM. Students, are you understanding this? The difference in the address allocation and also difference in object code generation. Are you guys understanding?
Yes, sir.
Yes, sir.
Any doubts still here, my dear students?
No, sir.
If anybody has any doubts, you can ask me. Okay. Now, so if you thinking that if you do not have, then I will go further. So that's how. Next, coming to the Reservoir 2 instructions. Definitely for the Reservoir instructions, you don't have to generate any object code because they are only the memory space allocation. As we spoke in the SIC also, we had given as much as explanation at that time as well. So it's only memory allocation for which you don't have to generate any object code. Right now, finally, let us write the object program. Finally, let us write the object program. When I write the object program, as usual, you have H followed by, so H followed by what? It is the name of the program. What is the name of the program? It is operation, but you can only fit within the 2 to 7. So you'll get 2, 3, 4, 5, 6 and 7. You will get operation, you can't fit it completely. You'll get 2, 3, 4, 5, 6, 7. You can only fit it within that. You can only fit operate. Okay, you can't fit operation within that because your field is only between the 2 to 7, followed by the starting address. What is the starting address for the program? It is as usual 6 zeros, right? You can't only write as 4 zeros because the field you have to fit it. Then followed by the length of the program. Now can you guys let me know the length of the program, how to find out? It is as same as what we did in the SIC as well. The last address minus the first address. The last address is what? 0016, followed by the beginning address is what? 006, sorry, 000. So 00016 minus 0000, you'll get as 0016 itself. So you'll get as, I'll write as 0000 and 16. That's the length of the program. So I'm done with the header record as well. Now when I start with the text record, okay, when I start with the text record, where exactly the first object code is available? First object code is available at the address zeros. So I'll write 0000 itself, which is where the text record is starting. And length field, let me leave out a space. Okay, then I'll start writing these object codes, right? I'll start writing those object codes. So I need to write, I'll start writing them in the continuous way. Okay, so there won't be any difference in the formats, and there is nothing where you need to make a difference in the formats and all that. So okay, continuously how to keep writing the object codes. But one thing is for sure, as we spoke in the SIC also, the maximum length in your text record should not exceed the length, which is, what is the length, students? What is the length?
10 to 69, sir.
69. Very good. So it should not exceed the 69. You have to keep that in mind, and then you have to keep writing. Now I don't think so we are exceeding that 69, so I'm just writing them. So in a single text record, if at all if it is going to exceed more than 69, definitely you have to stop that text record and write in the next text record. So I'm done with the text record as well, but I need to fill here the length of the text record. If you want to find out, you can find out the length. You can see 3, it is 3 bytes plus 3 bytes, 6 bytes plus 3 bytes, it is 9 bytes plus 2 bytes. 2 bytes means how much you get? Plus 2 bytes means 9 plus 2, which is 11. 11 plus 2, 13. 13 plus 3, 14. So 14, how to write 14 in the what we say that in the hexadecimal, how to write 14? It is 0E. 14. So the length of the text record is E. E means 14. 14 bytes is the length, right? And followed by end record, E followed by the starting address where your execution will begin. So this is the object program. So given the program, which is this sample program, or you can say the source program in SIC XC, and with the respective opcode values. So for which first you need to do the address assignment followed by the symbol table generation, by using which again as by keeping them in the mind, which is formats and also the addressing modes, we generated the object codes, and those we have written in the object program. Yes, any doubts?
So shouldn't the length be 16, sir?
Yeah, no. See, it is the length of the text record. That is where you have to be very clear. Here we are given the length of the program. In the header record, whatever we are given, it is the length of the program.
Each thing first has 3 bytes, then 3, then 3, 9, plus 2, plus 2, then again 3, no, sir?
Total how much? Okay, wait a minute, let's see. 3 plus 3 plus 3, 9. 9 plus 2 is 11. 11 plus 2 is 13. Okay, 13 plus 3 is 16. Definitely, that's good. So 16 means 10. Good. 16 means 10. Good. So finally, you'll be having an end record. So likewise, however we had in SIC also, your object program may contain any number of text records based on the requirement, but you will be having only one header record, one end record.